So, as I said, energy is not lost. What happens is that it transforms from one form to what? The same thing. I use human being now to liken to human being now. Remember, for those that have read, those Christians that have read the Bible, the Genesis, right? When they were talking about creation, they said that God got clay, right? Yeah. Clay, and do what? That is the spirit, the soul inside it, right? Yes. Now, and it came alive, right? Yes. Good. Now, if somebody dies, the person is not dead. Is this that same clay? This body is the clay. We go down to the clay where it came from. That's will now be transformed to another realm. Is that clear? Which some religious group, they call it what? Heaven, right? Heaven, right? Then, and it can be transformed to heaven or to hell, right? Some religious belief call their own heaven. Heaven meaning another realm that is better, very, very enjoyable. They will be dancing, they will be happy, they will be eating rice, they will, enjoy themselves. They are happy, right? They call it the one here, where there will be punishment, suffering, right? Now, other religious things call it, don't call it heaven and earth, heaven and the hell. They call it that the person would this body will go down to this thing, but the spirit, the inner self will now be transformed to another come back again to another world, or come back again in this world, but as a better person, right? Someone that is bigger, richer, enjoying his life, right? Yes. That is depending on what they did here on earth. If they did something good in this life, when they now transform to another, they will now be enjoying themselves. But if they did evil on this life, when they come back again in another life, they will be like they become ants, suffering, or they may be somebody that has very serious health issues or something that signifies that the person is what? Suffering lesser than what he was. That is different what? Beliefs. So it depends on their own what? Belief. But in all these things, whether each one you believe, in all these things, in all they're talking about what? Transformation. Right? Yes, transformation. Recycling. Transformation. The same thing now, that's what we brought into what? Law of conservation of what? Energy. So now, the energy can be in form of heat. It can be, we have heat energy, we have chemical energy, we have electrical energy, mechanical energy. It's other mechanical energy that we have kinetic and what? It's other mechanical energy that we have kinetic energy and what? But each of them, energy can move from one form to what? Another form. It can move from chemical to heat. It can move from heat to electrical. It can move depending on how you want, what you want. How you see that not convert it to where you can get equipment that can help it to convert from one form to what? Another. Look at your electrical iron, right? Yes. Look at your electrical iron, pressing iron. What happened? You plug it on the electric source. Yes. Energy, power, electrical power will supply energy, right? Yes. When energy, what is power? Power is energy per unit time, right? Yes. So energy is entering per unit time. That power is energy going per unit time. When they now enter the electrical iron, what happens? The content of this will convert it to what? Heat. Is that heat energy that will help your clothes that is rumpled to be pressed from electrical energy to what? Heat energy. Now, today you have light, right? Light, electrical power, right? Remember, that power came from where? Water. Water, right? From a dam, right? It can come from water. It can come from light, solar energy. You see, okay, let's assume it's coming from light, solar energy, photon, right?
Yes.
If it lands on the panel, it will transform it to what? Electrical energy. You plug an iron, the electrical energy become what? Heat energy, right?
Yes.
Look at your vehicle. The fuel they got from the deposits from petroleum. When petroleum is extracted, it will be what? Refined, right? Yes. And to get what? Petroleum, right? Yes. You now pour it in your generator or your car engine, and it will now be transformed to what? Mechanical energy with the help of electrical energy. And sometimes you may even use battery energy stored in the battery, chemical, transform it to what? Electrical energy, mechanical energy. Have you now seen energy transformations, right? Now, when you talk about heat, is this energy that is moving from a region of what? Higher one temperature what? The difference, right? Now, sometimes the temperature may be high. That we call it temperature gradient. Higher, this is high temperature, right? And this is what? Low temperature. Normally, heat flows from here to where? Is that clear? Yes. Yes. If you bring two things that are of this higher temperature and this lower temperature, this will lose heat energy. This object at higher temperature will lose heat energy to the one at lower temperature. And before you know what's going on, the temperature of this one will come up until they become the same. Have you noticed that? I said, these are two bodies, right? One at the higher temperature, one at the lower temperature. If you bring two of them together, there will be heat loss from this one. This will lose heat energy. And this will gain the heat energy lost by this one. And before you know what's going on, two of them will come at the same energy level. Heat energy. They possess the same level of heat energy. Typical example, get ice block. Ice block is approximately 0 degrees Celsius, right? Get ice block. Maybe at 0 degrees Celsius. Get boiled water. Maybe call it boiled and cool, or even do one that is even boiling. Let's say at 100 degrees Celsius. Take this thing at 0 degrees Celsius and put here. This will start melting. Do you know why it's melting? This will lose its heat energy to it. And when the ice block gains energy from this boiling water, the particles of this, told them are water, right? But the molecules of this ice block are together. There's intermolecular forces that hold them together as a solid. Now, when heat moves from this to this ice block, it will absorb that heat. The molecule will gain energy. And this average kinetic energy, the average kinetic energy will do what? Increase. And they will start vibrating. What's going on? It will melt. Because they are vibrating now. Because they don't have energy. They have been fed. Just as you may be weak. See as they are now. Get food now. Give them. They will start doing what? Vibrating. That what happens to these molecules of this ice block. And before what's going on, the ice block will melt. Then they will change from solid to what? Liquid. And before as heat is moving from this to this, the temperature of this one is going down. It may come to about 60 degrees Celsius. This one, the temperature is going up. It will move from 0 degree to maybe to 40. And before you know what's going on, the temperature of the entire final mixture may become 50. The temperature of the entire solution, liquid inside it, will become 50. You brought something that was 100 and mixed with something at 0. They will meet at a point. That's what is called loss of heat and gain of what? Heat energy. Am I communicating? Now, that's the word of introduction. Any questions so far? Any question? You are sleeping. Any question? So basically, heat is a concept of physics that deals with the study of relative motion of liquid or fluid from one body to another. So it's actually a form of energy. I have talked about it, right? It's a form of what? Energy, right? Good. And it is transferred from one body to another due to temperature what? Difference. I have explained that, right? Good. And it is actually a measure of total internal energy of a body. It is measured in joule. Joule, the SI unit is joule, right? Joule. Joule, joules, anyone you call it. Anyway, I call it. But sure, you know what I'm talking about, right? That's the most important thing. It's not by so many, it's by understanding what they are saying. You may be shocked that you may get the transcription now. It may not be this thing you are saying. Are you aware? All right. So now temperature. Having look at we talk about temperature. Temperature is what? The degree of what? Of a body. Good. So both heat and temperature are scalar quantities. They are what? Scalar. What are scalar quantities? What are scalar quantities? What are scalar quantities? It's not true. What are scalar quantities? What are vector quantities? Bagam. What are vector and scalar quantities? Is that it?
Yes.
What is magnitude? What is magnitude? So for 3 years in the secondary school, you be saying magnitude. You don't know what magnitude is.
Does not have direction.
What is magnitude?
Something, maybe something.
Something what? That's or size, right?
Yes.
So vector quantity has both. Vector quantity will have both. See, if you are studying, please don't continue living that. I don't know how you could do it. If you are studying and if you come across a word you don't understand, please stop and find out the meaning of that word. Is that clear? Stop. But if you don't understand the word, you will not know that thing. You only cram it. No, tell me now. If they ask you what is a vector quantity, you say a vector quantity is a quantity that has both magnitude and direction, and you don't know the meaning of magnitude. Do you actually know what a vector quantity is? No. Let's hello. Keep quiet, please. Now, if you ask what is a vector quantity, you say you open your mouth with all confidence and stand and say a vector quantity is a quantity that has both magnitude and direction. And they clap for you, right? Yes. But you don't know the meaning of magnitude. Do you actually know the meaning of what a vector quantity is? You don't know. You don't know what a vector quantity is. You just crammed it. Yes. Because you don't know what it means. Yes. You can't explain it. You only crammed it. Simple. Yes, now. Because the question can be explain what do you understand by magnitude. You look at them like that. You don't know what it means. So please, do not commit anything to your memory as you are studying without knowing it as a word. You know, English language is not a language. So that's why you should try as much as possible to any word you see you don't understand. Look it up. You must not, things have changed. Not during our own time where you carry big dictionary up and down. With your phone, you can Google it and find out the meaning. As within few seconds, you continue your word. You continue your word. Simple, please. I beg you. Right now, so temperature is okay. Temperature, both temperature and heat, they are what? Scalar quantity. So scalar quantity are quantity that have only what? Magnitude. Just their magnitude, but vector has both magnitude and what? Direction. Good. So temperature, please, temperature and heat. Sometimes you see them used, to a layman out there, they use them interchangeably. But we that are in the science world, we know that they are not the same thing. Is that clear? That they are not what? The same thing. Yes. That they are not the same thing. So the unit of temperature is what? What is this? Okay. Which one is which one is the SI unit, Gogo? It's Kelvin now. But Fahrenheit, Celsius, Kelvin, they are units of what? Just as you have mass now. We have gram, we have kilogram, we have a lot of them. We have microgram, we have a lot of them. But the one that is the SI unit is what? Kilogram. Is that clear? Yes. So, are you with us? Are you sure? So that's the temperature, right? The temperature is what? Degree of hotness or coldness of what? Fever. Now let's look at the difference. Tell me now, what is it? Tell me, share with me the difference between temperature and heat and temperature. If you're asked now to differentiate between heat and temperature, what are you going to say? You say what? I agree with you. Another one. Another one. Temperature is the degree of hotness. Why is what? The measure of the huh? You say what? You say? I'm listening.
I'm listening. Oh yes. It can be transferred from one body to another body, while television cannot be transferred.
Another person. You said something. You mixed up something. Stop. You mixed up something. Repeat that thing you said again.
Temperature.
Uh,
Is the degree of hotness and coldness.
I agree with you.
Heat. Is the hotness.
Okay, temperature, heat is a measure of total internal what? Energy of a body. But temperature is the measure of what? Degree of what? Hotness and coldness of a body. So temperature is not about the energy itself. It talks about the degree of hotness and coldness. Is that clear?
Yes.
But heat talks about what? Measure of the total internal energy of your body. Is that clear?
Yes.
Now, and we are giving how many now? 4, right?
Yes.
Or 3. And please, I want to tell you, in my class, anytime you see me in your class, please, I will advise you to record my lectures. Record it. Because once I start teaching, I don't even know what comes out from my mouth again. Is that clear? Just record it, feel free. It will help you. Record it as you, if you want to study, you listen to that. Is that clear? Listen to it. Listen to read what you have in the course material, then browse too, right? To get more information. Go to textbooks. In fact, there are some apps that you can even use to change, to convert what you recorded to what. If you don't have time to be listening for a long time, you can convert it and make some correction. Those apps may not be able to give you the exact distance. Exactly. And sometimes, if due to my pronunciation as an African man, I don't pronounce like them. It may give wrong distance. You cannot correct it and have it add it up in your note. I'm giving you clue to scatter A's everywhere in my courses. Record it. Whatever I say in my class, whenever I want to set question, they'll just appear. I'll start setting them. So my question doesn't limit only the way it is in your course material. That's why I don't train people that cram and pour. I train people that study it and know it. Is that clear?
Yes.
If I give you exam, maybe if it is essay or whatever, even if you don't need to give it to me the way it is in my material. Once you are writing what makes sense, I'll give you your full mark. Is that clear?
Yes.
Because I'm not training robots. I'm training human beings that reason.
Yes.
Is that clear?
Yes.
So please, that's why I encourage you, record it. Feel free. You are free. So we have mentioned 4 now, right? Another one. Think.
It is the energy in transmit. Why?
In what?
Transmit. Why energy is it some? Why temperature is it thermal energy?
It's okay. You remember your kinetic theory of matter in your secondary school? I'll be going back to that secondary school. If you miss it, sorry, I'm going back because that is why I'm here. I'm linking up your secondary school physics, chemistry. I'm linking it up so that if you not do well there, it will help you to. So I'm going back there. Sorry, that's what I was asked to do. So now, remember your chemistry. We talk about kinetic theory of matter. Hi there. When you talk about that, the temperature is a measure of the average kinetic energy of the molecules of a substance. Measure of average kinetic energy, not total internal energy. Total internal energy. Now, remember, it's a measure. Remember, when I was discussing something here, listen, I told you something here that once this thing absorbs energy, their kinetic energy will do what? Increase, right?
Yes.
And the temperature will be what? Increase, right?
Yes.
So what it means is that the more the temperature is rising, the kinetic energy will also be what? Increasing, because they will gain more energy and keep vibrating, break down the intermolecular forces, and be free from solid to liquid, from liquid to what? Gas. Is that clear? Good. So heat deals with transfer of thermal energy from one substance to what? Another, due to temperature what? Difference. But temperature measure the average kinetic energy. C. I don't call notes. Is that clear? I don't call notes. If I were you, I'll get my phone and keep it. As I'm talking, it's recording. You now try to follow what I'm saying, try to understand what I'm saying. Is that clear? The one you can put down, you put down. Try to understand what I'm saying. You listen critically, follow up. Then, when you get home, you replay that thing that you recorded. You can be pausing it and be making your note from it. You pause it, copy. Pause it, copy. Before highest 1 hour, you have copied everything that I discussed with you. And now, if you bring it to read, man, it will flow in. Because you listened and followed the lecture and recorded it. When you cannot get home and play it and stop, and write it down. If you read it, you don't even need any other textbook again. Is that clear?
Yes, sir.
You pay me for this clue now. I'm sharing my secrets with you. When I was in when I was in university, then there was no phone now. Then there was no phone. I used to have what is it? What is it? Then I used to buy. I have this recorder, right? I used to buy empty cassette, empty cassettes. I buy it in packs and keep. If I enter class, I just put it, keep it one side. I'll be recording lectures. If I go home, I'll just try to copy it back. One day I was taught by one lecturer. He warned me. I was like, wait now. Why is he warning me not to record it? I said, okay. Since that day I stopped. I told myself I will not do like that. My students will record it because I know it helps. I know it helps. I don't know about other lecturers, but for me, feel free. Is that clear? And I also record my lectures too. I have YouTube channel. So if you have that data to watch, when you can go and watch it if you want to, if you have data. But if you don't have data, that's why I advise you record it yourself. But if you are too weak or lazy to record, no issues. I'll give you a link after you go and watch it there or listen to it. Just it's my YouTube channel is Chetana TV. That's all. Chetana TV. Just go to Google and type at Chetana TV. I am almost in all the popular social media. Huh?
Are you on TikTok?
Yeah, I am everywhere.
Facebook, sir.
Everywhere.
Even Facebook.
Look, let's continue, please. Just check at Chetana TV, and you are good to go.
Is it Chetana TV? Yogi Knife?
Chetana TV.
Fair on me.
No, I'm still Chinese TV.
Because I've seen a lot of it.
All right, let's go. Just use ads. People can just, there are some social media that permit people using, but you cannot use this. What you cannot use is username. Nobody can have this username in the whole world now. On Facebook, YouTube, Instagram, nobody has this username now. You may just type. In fact, what am I even saying? Type my name, you see my works scattered everywhere. I sing too. Yes, I sing too. I sing. I act.
Okay, Facebook. No, it's YouTube.
All right. So let's not allow you to distract us. Let's continue. You can do that one. You can do that later, please. Let's continue. So we have seen the yes. We have seen different what is it called? The differences between temperature and what? Heat and temperature. Now let's look at measurement of temperature. Let's look at measurement of temperature. Don't worry, you can do that one at home. Let's conclude so you can go and rest.
We are tired.
I don't want to come back to the class.
All right, let's look at please, silence, please. Let's look at measurement of temperature. So sometimes, if I'm able to record my lectures, I upload it. And sometimes, if I have time at home, I'll just record lecture video and upload. It helps my students in different parts of the world to study. I also organize online tutorials. So for those interested. Now let's go now.
It's for free, right? Is it for free?
Free the
Online.
tutorial.
Like the videos is to post like
Free. Yeah. But online tutorial as in tutorial, that one is not free. After now we are after we talk about. Chat me up now. We are in class, so chat me up. We are in class, so chat me up. We are in class, please. Let us know. I just said let me chip it in.
Like last week, please come and meet me.
All right, now. So what is the instrument used to measure temperature? Thermometer. Good. That one is common. Thermometer. So temperature is measured by using what? Thermometer. So in fact, thermometers have two reference temperatures, or we call them fixed points. We have the one we call upper fixed point and lower fixed point. Some people did physics. Have you done it in this class?
No.
Okay, you still do it now. I believe. Okay, what have you done? Don't worry. By the time we are done, what we are doing here will help you. It's okay. What you are doing in this tutorial will help you understand better what you are doing in class. Exactly. Just try to. So we have the upper what? And lower fixed points. Upper fixed point and lower fixed points. So what is upper fixed points? Tell me what you know about the upper fixed point. Huh? Huh? I agree. At what degree is high temperature? I agree with you. 100 watts. Good. I like that. So upper fixed point is the temperature of steam. Are we together? Upper fixed point is the temperature of steam from pure water. It's temperature of steam from pure, not just hope you know that impurities increase boiling point. Are you aware?
Yes.
Impurities affect the boiling point, right?
Yes, sir.
Of liquids. If there's an impurity, the boiling point of a liquid will increase more than the higher than what temperature at which it was supposed to do what? Boil. Is that clear?
Yes.
Yeah. So sun like water now, pure water boils at 100 degrees Celsius. So upper fixed point is the temperature of steam from pure water boiling at standard atmospheric what? Pressure. What are the standard atmospheric pressure? Yeah, tell me. What are the standard atmospheric? Tell me the STP.
22.5.
Standard atmospheric pressure is what? 2.5 what? DMQ. No. If you are talking about molar volume of gas. I'm talking about pressure now. Atmospheric pressure. It can be millimeter mercury. It can be in
400.
no.
760.
Good. 7 what?
60.
Don't worry, we'll still get there. I just want to, I just want to stimulate your appetite. We'll still get there, okay? So is that temperature? The upper fixed point is the temperature of steam. Steam from what? Pure water boiling at what? STP. So in this STP now, the pressure is what? 760 millimeter mercury, and the temperature is what? 100 degrees what? Celsius. Are we together?
Yes.
So the upper limit temperature in Celsius. So I'm not. We are not looking at it in Kelvin or in Fahrenheit. It's in Celsius. What? 100 what? Degrees Celsius. Now, what of lower fixed point?
0 degrees Celsius.
Good. So lower fixed point is the temperature of pure water. Sorry. It's the temperature of pure ice. Pure melted ice, not just because if you say water. Is ice water, ice block. Is ice water? Okay. Ice steam. Ice steam. Are we together?
Yes.
Look up. We say are we together?
Yes.
Look up. I want to explain something. Look up. Ice, water, steam. All of them. This whole thing. Ice is water. The one you call water is still what? Steam is what?
Water.
But the difference is what? This one is solid.
Liquid gas.
Liquid water and what?
Gas.
But each time we say water, our mind will go to only this one, because this is the one at our temperature now. This part of the world, the water we know is one in liquid form. Are we together?
Yes.
Do you know that there's some part of the country you go, the water they know is what? Ice. Just at their normal, the water they see around is what? Solid water. So if they need liquid water, they'll go and do what? Melts. If we need in this part of the world, if we need solid water, solid water, we'll do what? Freeze. We do what? We freeze. Are we together?
Yes, sir.
So
Together we are.
So the lower fixed point is temperature of pure melting ice at STP. So at STP, the pure melting ice, the temperature in question now is what? 0 what? Degrees Celsius. Are we together?
Yes.
0 degrees Celsius. So with this now, you will agree with me that that the substance of this whole thing is still what? H2O. It's only moving from one form to what? It's only moving from one force depending on the temperature and energy level. Is that clear? The energy in question. Now, we'll still make use of this upper and lower limit by the time we enter calculation. Is that clear?
Yes.
So now let's look at temperature scales. Temperature scales. Let's look at temperature scales. Who can tell me the interval, the difference or interval between the upper limit and upper fixed point and lower fixed point? What is it called? The difference or the interval between the upper fixed point and the lower fixed point.
The upper fixed point is the temperature is 100 degrees Celsius.
That interval, what is it called? You are laughing. Why are you playing? Yeah, stop. Tell me.
Temperature of
It has a name. The difference or interval between the upper fixed point and the lower fixed point. It has a name. What is it called? No, I'm talking about the look at upper fixed point, right? Look up. Upper fixed point is here, right? Yes. Lower fixed point is here, right? Yes. Right? This is upper fixed point, 100 degrees Celsius, and this is lower fixed point, 0 degrees Celsius. The interval between two of them, from here to here, is called what? No. It's called fundamental interval. So the difference in temperature between the upper and lower fixed point is called the fundamental interval of a thermometer. It's called the what? The fundamental interval of a thermometer. So that is the difference in temperature between the upper fixed point and lower fixed point. It's called what? Fundamental interval of a thermometer. We will study physics like nursery school people, so you can enter where. Is that clear? Yes. So it's called what? Fundamental interval of a thermometer. So the interval from here to here is called what? Fundamental interval. If you get a thermometer and look at it, for some of you that have seen your clinical thermometer, right? You see the scale there, right? It starts from 0, 100 on top, right? The interval, the calibration between that 100 and 0 degrees is what you call what? Fundamental interval of that thermometer. Is that clear? Yes. So based on that, now we have different scales now. We have different scales now, right? Now, so the fundamental interval may differ from one scale to another scale, though. Hope you know.
No. How?
Yes. Why? Okay, tell me the scales of temperature measurement you know. Or scales in temperature scales you know. Yes. Scales, you mentioned it in this class now. In fact, we were singing it. Who said that? God bless you.
What do you
I just scales. What are they? Name them. Celsius, and Kelvin. Good. There are the three scales now. Celsius, Fahrenheit, and what? Kelvin. Another name for Kelvin is absolute scale. Is that you call it Kelvin or absolute? Is that clear? I've told you that temperature. Okay, based on this now, temperature has units, which can be Fahrenheit, right?
Yes.
Which can be Celsius and what? Kelvin. But the SI unit is what? Kelvin. Please note that point, okay? Temperature can be in Fahrenheit. In fact, there's some part of the world you will go. Their measurement is what? Is what? Fahrenheit. Yes, I've seen it. Is that clear? So, but basically, you know, SI unit means system, international system, where a system where the whole world agree that this is what we can be using to avoid discrepancies. But we have different units. Different countries use different units of their choice. But internationally recognized one is what? SI unit. Kelvin. Is that clear? Yes. That's the meaning of internet. SI is from French. This I cannot pronounce it, but I don't know French. Système international, but it means international system. Is that clear? In English language.
What do you call it?
I don't know how to speak French, but I know that SI comes from French. Is that clear? Yes. But if you translate it to English, it's international what? System. So in our next class, are we together?
Yes.
In our next class, you know, today was more like introduction, right?
Yes.
So in our next class, we go to in our next class we go to thermometer. That is the purpose of this tutorial. Is that clear? We move to thermometer. Right. Thank you very much. Class rep, please. Class rep, give me attendance of this class. Please. Did you hear me? Please ensure you read attendance. So Monday, give it to me. Send me this. When you are done, send me this. Just take the picture of it and send me. By Monday, you will give me the hard copy. Is that clear?